Good day everyone, welcome back to our continuation on our discussion on the topic application of differentiation. Today we'll be briefly discussing stationary point, turning point and point of inflection. Now we'll be using this graph to explain the concept of stationary point, turning point and point of inflection. As you can see, all the points are indicated on the graph for simplification. Now the very first concept is stationary point. Stationary points are points on a curve where the y over the x is equal to 0. Basically, they are points where a curve changes direction. So at stationary point, the y over the x is equal to 0. Now the next concept is turning point. Now turning points are the points where a curve changes its direction from increasing to decreasing or from decreasing to increasing. All turning point are stationary point. It is very important to know that all turning point are stationary point, but not all stationary points are turning points. We have two types of turning point. One is the maximum and the other is the minimum. Now in the maximum, the curve changes from increasing to decreasing, while at minimum the curve changes from decreasing to increasing. Now the third concept is what? Point of inflection. Now point of inflection is the point in a curve where it changes its concativity, or where it changes from being concave up to concave down, or vice versa. Now both points of inflection at turning point are stationary points, and at both turning point and point of inflection, the y over the s is equals to 0. Our first question is from NECO, and it states that what are the stationary values of the function y equals to s cubed minus 2s squared plus s? Solution. Now the very first thing we are going to do is write down our equation y equals to s cubed minus 2s squared plus s. And we know that at stationary point, the y over the s is equals to 0. So the first thing we are going to do is differentiate our equation. Doing so, the y over the s is equals to 3s squared minus 4s plus 1. Now equating the y over the s to be equals to 0, it becomes 3s squared minus 4s plus 1 is equals to 0. At this point, to get the value of s, we are going to factorize. Now factorizing, we are going to be looking for two factors in which when we multiply them, it will give us the product of a and c, and when we add them, it will give us b. Now from our quadratic equation, our a is 3 and our c is 1. So the product of a and c is 3. Now find the two numbers. When we multiply that will give us 3, and when we add them will give us minus 4. The numbers are minus 3 and minus 1. So splitting minus 4s into minus 3s and minus s, it becomes 3s squared minus 3s minus s plus 1 is equals to 0. Now factorizing, it becomes 3s in bracket s minus 1 minus 1 in bracket s minus 1 is equals to 0. Now since the elements in our brackets are the same, we can factorize it further to 3s minus 1 in bracket s minus 1 is equals to 0. At this point, 3s minus 1 will be equals to 0, or s minus 1 will be equals to 0. Or therefore 3s will be equals to 1, or s will be equals to 1. Simplifying 3s equals to 1, it becomes s equals to 1 over 3. Therefore s equals to 1 over 3, or s is equals to 1. Now we are going to be looking for the corresponding value of y when s equals to 1 over 3 and when s equals to 1. When s equals to 1 over 3, y will be equals to 1 over 3 cubed minus 2 in bracket 1 over 3 square plus 1 over 3. Simplifying, it becomes y equals to 1 over 27 minus 2 over 9 plus 1 over 3. Solving the fraction by finding the LCM, which is 27, it becomes y equals to 1 minus 6 plus 9 divided by 27. Simplifying, we are left with y equals to 4 over 27. Doing same for when s equals to 1. Y will be equals to 1 cubed minus 2 in bracket 1 square plus 1, which simplifies to y equals to 1 minus 2 plus 1, which is equals to 0. Therefore, our stationary points are for 1 and 0, and also 1 over 3 and 4 over 27. That's 1 for s, 0 for y, and 1 over 3 for s, and 4 over 27 for y. Our next example says that given that f of s equals to s squared plus 3s plus 1, find the value of s at the turning point. Now the first thing to write down our equation, f of s is equal to s squared plus 3s plus 1. Now our turning point, the y over the s is equal to 0, or f prime of s is equal to 0. So differentiating our equation, f prime of s, or the y over the s, is equals to 2s plus 3. Now recall that the y over the s equals to 0 at turning point, so we are going to be substituting 0 for the y over the s. Doing so, 2s plus 3 will be equals to 0. Simplifying further, 2s will be equals to minus 3, and when we divide both sides by 2, s will be equals to minus 3 over 2, or minus 1 whole number 1 over 2, and the correct option is C. We have another example that states that if y is equals to s cubed minus s squared minus s plus 6, find the value of s at the turning point. Now the first step is to write down our equation, y equals to s cubed minus s squared minus s plus 6, and at turning point the y over the s is equals to 0. So differentiating our equation, the y over the s is equals to 3s squared minus 2s minus 1. So equating it to 0, because the y over the s is equal to 0 at turning point, it becomes 3s squared minus 2s minus 1 equals to 0. Factorizing, we are going to be looking for two numbers in which when we multiply them, it's going to give us the product of a and c, and when we add them, it's going to give us b. In our equation, our a is 3, our b is minus 2, and our c is minus 1. So we are looking for two numbers in which when we multiply them, it's going to give us 3 times minus 1, which is minus 3, and when we add it, it's going to give us minus 2. The two number is minus 3 and plus 1. So splitting minus 2s into minus 3s and s, our equation becomes 3s squared minus 3s plus s minus 1 is equals to 0. Factorizing further, it becomes 3s in bracket s minus 1 plus 1 in bracket s minus 1 equals to 0. Since the elements in our brackets are the same, you can factorize this at 3s plus 1 in bracket s minus 1 is equals to 0. At this point, 3s plus 1 will be equals to 0, or s minus 1 will be equals to 0. Therefore, 3s will be equals to minus 1, or s is equals to 1. Now simplifying 3s equals to minus 1, s will be equals to minus 1 over 3. Therefore, the turning points are 1 and minus 1 over 3. And the correct option is D. Our final example is from NECO 2012. It states that find the values of s at the turning points of the curve y equals to 4s cubed minus 3 in bracket s squared plus 2s minus 1, and we are given the options. Now in our solution, the first thing we are going to do is to write down our equation, which is y equals to 4s cubed minus 3 in bracket s squared plus 2s minus 1. Now we are going to be expanding our bracket. Doing so, our equation becomes y equals to 4s cubed, and when we multiply through by 3, minus 3s squared minus 6s plus 4. Recall that at turning point, the y over the s is equals to 0, and when we differentiate our function, it becomes the y over the s is equals to 12s squared minus 6s minus 6. Now equating the y over the s equals to 0 in our answer, it becomes 12s squared minus 6s minus 6 equals to 0. And to simplify it further, we divide all through by 6. When we divide all through by 6, we are left with 2s squared minus s minus 1 is equals to 0. Factorizing, we are going to be looking for two numbers in which when we multiply them, it is going to give us the product of a and c, and when we add them, it is going to give us b. In our equation, our a is 2, our b is minus 1, and our c is minus 1. So we are looking for two numbers that are going to give us the product of a and c, which is 2 and minus 1, which is minus 2, and when we add them together, it is going to give us minus 1. The two number is minus 2 and plus 1. So splitting minus s into minus 2s and s, our equation becomes 2s squared minus 2s plus s minus 1 is equals to 0. Factorizing further, it becomes 2s in bracket s minus 1 plus 1 in bracket s minus 1 equals to 0. Factorizing further, it becomes 2s plus 1 in bracket s minus 1 equals to 0. At this point 2s plus 1 will be equals to 0, or s minus 1 will be equals to 0. Therefore 2s will be equals to minus 1, or s is equals to 1. Simplifying 2s equals to minus 1, s will be equals to minus 1 over 2. Now our turning point is therefore minus 1 over 2 and 1, and our final answer is B. We have some exercises for you to try your answer on at home. For more insight on the topic, you can check our Hidden Facts Further Mathematics textbooks, which you can easily get in bookshops, or if you are interested in the soft copy, you can get that at the website at the corner of the screen. Thank you.